First thing I noticed about this problem is they give you the given alkane, which is C20H42. Also gives you sample rainwater that is 0.2 parts per billion, and it has a density close to 1 gram per milliliter. So you can break down the 0.2 parts per billion into 0.2 parts alkane over 1 billion parts H2O. So you want to take the given parts alkane and the parts per water, and you can convert parts per billion into grams. So it's 0.2 grams alkane over 1 billion. And you want to convert that into moles. So when you want to convert this into moles, you take the molar mass of this, which is roughly 12, and this is 1. So it comes out to be about 282.536 grams per mole. So you want to put 1 mole over 282.536 grams, which gives you your moles per gram of solution, which is 7.0787 times 10 to the negative 13th moles per grams of solution. But it wants you to find the molar concentration, which is moles per liter, so you need to change the grams per solution into the moles per milliliter. See, this is just a strictly units conversion. So you take 7.007 87 times 10 to the negative 13th moles per gram of solution, and then you convert those into moles per milliliter. So if you want to do grams of solution over milliliters of solution, which allows those to cancel. So then it just comes out 7.0787 times 10 to the negative 13th moles per milliliter. So then once you get moles per milliliter, you need to make it moles per liter. So 7.0787 times 10 to the negative 13th moles per milliliter times 1,000 milliliters over 1, which equals your molar concentration, which is 7.08 times 10 to the negative 10 moles per liter. When working these problems, it's important to understand that you can't just memorize the numbers, you have to understand the process. So I'm going to go through this problem again, yet change a few things. I'm going to change the molar mass of the alkane, and I'm going to change the parts per billion into parts per million. So let's make it C10H22 parts per million. First thing you're going to notice is, hopefully you notice, is that the C10H22 is going to have a different molar mass. So you add up the molar mass. So molar mass of carbon is about 12, hydrogen's 1. So it's going to come out to be about 142 grams per mole. You notice that it's parts per million this time, which is going to change pretty drastically from billion. And then you notice that your density is going to be about the same still. First thing you want to do is notice that your parts per million is 0.2 parts alkane over your parts per water, which is 1,000,000 this time, not 1,000,000,000. after you do this, you're gonna know it's 0.2 grams alkane over 1 million parts water. And you're gonna take this and you're gonna multiply it over a mole, which is the molar mass of C10H22, which is 142 grams. And you're gonna get about 2 times 10 to the negative 7th moles per grams of solution. Once again, you have to recognize that you can't get a molar concentration from moles per gram per solution. So you're gonna have to change, this is strictly units, so you're gonna have to go 2 times 10 to the negative 7th moles per gram solution. And you're gonna have to change it from grams of solution to milliliters. So it's going to come out to be 2 times 10 to the negative 7th moles per milliliters. And you should know that you can't have moles per milliliter if you want a molar concentration, because the given is moles per liter. So you're going to take this concentration, times it by 1,000 milliliters to 1 liter, and it's going to give you 2 times 10 to the negative 4th moles per liter, which is your molar concentration.